Hi, my name is Atiya Tahiri. I'm a PhD student working in the Perception Engineering Lab in the CS department at UCSB. And I'm excited to present our work on developing hands-free video game controllers for quadriplegic individuals like me. In this talk, I'm going to walk you through the problem identification, the solution we created, and the design process for building a hands-free game controller. Over the last several decades, video gaming has undergone tremendous technological and cultural change. However, playing video games requires motor skills when using standard input devices like the keyboard, mouse, or game controller. This makes games inaccessible to people with mobility impairments, affecting over 8.3 million people in the US alone. Individuals who would benefit most from games are often unable to play. There are several video game interaction devices that do not require using hands, including brain-computer interfaces, eye-gaze controllers, mechanical switches, mouse, and turn-based controllers. However, these devices are limited in input compared to the complex input that traditional games require. I can tell you, the user experience is not quite the real thing. We used the assistive technology design approach to develop a game input system for a quadriplegic individual who's me. The goal was to identify muscles that I could easily use and use them for input. While all 80 devices for people with disabilities are based on this concept, they show two major drawbacks for me. First, I'm uncomfortable wearing a wearable device, and second, my physical disability severely limited me in almost all areas. We use facial expression recognition to provide the capabilities of a complex standard input device. The only hardware needed for this approach is a camera, which users most likely already own. I was the researcher in this project, but also since I have been affected by SMA since the age of 1, I was also the target user. Trying to overcome my own limitations while finding ways to help others was an empowering process for me and made me realize that I can really make a difference in people's lives. Here is an overview of our pipeline. Our primary input method is the user's face as detected by a camera. We process the video stream in real time using OpenFace 2.0. Our secondary input method is speech, which we convert to text using Windows Cloud Speech API. Output from OpenFace or speech is mapped to the keyboard, and each key is then mapped to an action in each video game. For testing our pipeline, we built 3 different video games using the Unreal Engine. Each facial expression is composed of a set of facial action units. Action units, or AUs, described by the facial action coding system, refer to a set of visible facial muscle movements. We use OpenFace Rotate to detect facial AUs in real time from the input video stream. We use a total of 14 AUs in our system that define these 6 main facial expressions. AU detection is done in 2 ways. 1. AU presence or absence, and 2. The intensity value of an AU. We support both in our system, but we let the user select the type of facial expression in a graphical interface that we built. If they choose intensity, they can then adjust the detection threshold in the next step. All changes are immediately available for use in the video games. Here is a key mapping table for the first-person shooter, one of our own 3 designed games. We focus more on the FPS here, as it is a complex and demanding game. A specific facial expression or sporting keyboard mapped to a key is assigned to a game action. I'd like to invite you to watch a short video of me playing our FPS game. To best adapt the system to the player's strengths, the system was designed and tested in an iterative way. We also took into account the frequency of game actions. In the FPS game, for example, shooting is required many times and is crucial for survival. We used the facial expression I was most comfortable with for these repetitive actions. We considered multimodal input and feedback. Response time can vary from video game to video game, so relying on a single input system can limit the types of interaction and thus the games that can be played. We support the facial expression-based input with a speech input. Most importantly, we designed the games with flexibility and personalization in mind to provide a fun gaming experience for all. Cutting the game speed by half or implementing auto-aiming for shooting and so on are some of the many configurations we did and several iterations after playtesting. Besides our own pre-designed video games, we have also successfully tested the system on 4 existing consumer games without making any changes to the system. We created macros for complex game actions to map multiple input keys to a facial expression. We have also included audio feedback for when the user switches between macro and non-macro modes. Given how easily our system works, we hope that more games studios will enable keyboard remapping in their games to increase inclusivity. In this research, we have built a fully functional, hands-free video game controller based on facial expression recognition for individuals with quadriplegia. We took a collaborative design approach for design and testing. We designed 3 different PC games for playtesting with emphasis on user agency, user comfort, memorability, and ease of use. Thank you.